Okay. The second technique is technique in the spread spectrum is direct sequence spread spectrum, which is called as D/SSS. Okay. So this technique, what happens is it also expands the bandwidth of the original signal as comparatively to the FHSS only. Okay. It also expands the bandwidth of the original signal, but the process is somewhat very different here in as comparatively to the FHSS. So in DSS, what happens is whenever we get a bit pattern here, 101 is nothing but our bit pattern, we replace each data bit. So this is one data bit, we replace each data bit with n bits here. Okay, if the pattern is 101, 1 is replaced with n bits, 0 is also replaced with n bits, and even 1 is replaced with again n bits. So here every bit is replaced with n bits. So here we have to decide what these n bits will be. Means we have to decide the pattern of these n bits first. Okay. So in other words, here each bit will be assigned a code of n bits, which we call these n bits as chips. This is nothing but the chips here. Okay. Now we'll see with the diagram how it exactly works. So this is the diagram of a DSSS wherein the original signal is present here. So this chips generator will generate a spreading code. Okay, this chips generator will generate a spreading code and it is given to the modulator, and after the original signal is encoded with this chips generator, we are getting the spread signal. Here we are getting the extended bandwidth rather than the original bandwidth here. So when we consider as an example in a wireless LAN, okay, so here we are considering an example here, okay, where we are treating n is equal to 11, means the number of n bits we are encoding for each data bit. So that n bits will be 11 bits here. Okay, suppose those n bits are nothing but 1 0 1 1 0 1 and 000. So even you can observe that the sequence which we are encoding, that is same for all the bits here. For 1 we are also taking the same pattern, that is n bit pattern. For 0 also we are taking the same n bit pattern, and for 1 also we are taking the same n bit pattern here. Now we will see how exactly this example works. So whenever a pattern is generated, that is 101, and we are keeping the spreading code, we are multiplying the spreading code with the original signal in order to get the spread signal here. So when this spreading code is usually, it is illustrated in case of polar NRZ technique. I hope everyone remembers the polar NRZ technique, which we have already discussed in the previous classes. So in polar NRZ technique, what happens is the 1, so this 1 is represented as positive voltage and 0 will be represented as negative voltage here. So the same sequence follows. 1 is positive, 0 is negative. 1 is positive and 0 is negative. This is positive and this is negative. The same applies for the whole sequence here. Okay. So when we multiply this original signal with a spreading code, we will get the spread signal. So in the spread signal, what happens is whenever there is a bit 1, okay, the input bit is 1, so that remains the same in case of a spread signal, means the output remains the same in case of a spread signal. But whenever the input bit is 0 here, so this will be in a reversed manner in case of a spread signal. So how it is reversed? So when it is an positive 1 in case of a polar NRZ, that is spreading code, in the output signal it will be negative of it. 0, if it is negative, this will become positive. Same way the sequence continues here. So this is how it is illustrated, or it is converted into a D/SSS. Okay. So the spread signal, so this spread signal can provide privacy if the intruder does not know the code. Okay, this code should be kept secret here. If the code is kept secret, then we can definitely achieve the privacy here, because the intruder never gets to know what is the code is. Okay, and it also provides immunity against the interference. If at all someone is ready to hack the data in between, it provides the immunity, means it will not allow the intruder to hack it. So that is nothing but the immunity here. It also provides the immunity against interference if each station uses a different code. If the code is different for each of the bits here, then it also provides the immunity against the interference, means no one can hack it in between. Okay, so this is the technique of DSS. Now today we have discussed in all the three videos, we have discussed first about the spread spectrum technique, next about the FSS, which is the first technique in spread spectrum, and the second technique is DSS, that is direct sequence spread spectrum. So this completes the whole technique of spread spectrum.